Okay, uh, welcome back. In this session, we will see orthographic projections, that is how to convert an isometric drawing into an orthographic drawing. So, you all know the basics of basics of orthographic projections, I think. So, whenever you see this kind of arrow mark, that indicates the front view of the component. So, the rest of the sides depending upon which side it makes sense, right? So if this is front view, this side is going to be my left side and this is going to be my top view. So while drawing in the drawing sheet, we will draw the front view first, top view in the bottom, left side view to the right side. Or if it is a right side view in the component, we will draw it left in the left side of our drawing sheet. These things we all know that depend upon the first angle and third angle projections. We will use that, right? So now I will let you know how to draw this diagram or how to convert this isometric drawing into an orthographic drawing. Right. To start off with, initially you just draw an axis point, right? All these things should be pretty thin. Only your final component should be thick, right? So what I will do is I will just draw a random thin line, and then I will just represent this as x dash, y dash, and y. Now I'm going to draw my drawing inside this. So to start off with some equal distance, I will just take some 2 centimeters this side and some 2 centimeters that side. Okay, we'll take some 20 mm here and 20 mm here. I will just draw a thin line, very thin lines we should draw. I will just draw some very thin lines. Similarly, two to the top, two to the top, and two to the bottom. Again, I will draw very thin straight lines. Similarly, I will draw thin lines. So these lines will represent that. Okay, I will start my drawing from some equal distance so that it will be pretty neat. So this axis line is quite important. So this is my drawing now. I'm going to draw this. So this is my front view. This is my left hand side view. This is going to be my top view, right? So in the paper I will draw the front view here, top view here. This is my left hand side view, so I will draw it to my right side, that is to the right side of my drawing sheet. So for example, I will draw the front view here. This is the front view, right? So I will draw the front view here, and I will draw the top view here. Maybe I will sorry, I will just erase it and write it on the top. I will draw the top view here, and I will draw the left side view to the right side of my drawing sheet. Okay, left side view to the right side of my drawing sheet. So this is going to be my left side view. So I think you are clear on that. The next step here is to find out the total length, total breadth, and total height of the component. Okay, and these things I know. See, for example, this is a component like this. You have a component like this. Okay, and this is going to be a front, let us assume, right? So the length or the distance in front of your front view will always be its length. So the side view will be always have its breadth, and this will have its height. So here you will have your height, here you will have your length, and here you will have your breadth, right? So now my component, in my component I need to find the total length, total breadth, and total height. So as I said earlier, the distance or the measurement in front of your front view will be always your length. So the total length of the component will be 60. So the total length will be 60. The total breadth, that is side view, in your side view you can see a measurement that is going to be your breadth. So your base is going to be your 50, and height, as you can see, from here to here it is 45. Again you have a 15 mm height over there, right? Then 45 plus 15, it is going to be 60. So length is 60, breadth is 50, and height is again 60. So I have found out all those components. Now while looking from the front view, while looking from the front view, you can see your length and height. Height is 60, breadth is 50, and length is also 60, right? While looking from the front view, you can only see the length and height, right? You cannot see all those things. So while looking from the front view, I can see the length and height. Similarly, while looking from the side view, I can see the base and height, right? Okay, side view, I can see the base and height. And from the top view, I can see my length and breadth. Length and breadth. This you should mark it first, right? So from the front view, I can see my length and height. From the top view, I can see the length and breadth alone. From the side view, I can only able to see my breadth and height. This you should now the next step after drawing all these things is to cover the given drawing into a rectangle. So the dimensions of the rectangle will depend on this. So as far as this is concerned, here is going to be my front view, here is going to be my top view. In diagram, my left side view is given, so in the paper I will draw it to my right hand side. So this is going to be my left side, right? Now initially what I will do is I will draw the rectangle of these respective lengths. For example, in the front view I have length into height, right? What is length? 60 and height is 60. So I will just draw a rectangle of 60 comma 60 to my front. I will just take 60 mm over here. Okay, I will mark it, and from here again I will have a 60 comma 60, right? So I'll just draw. Again, these should be very thin. Again, only your final drawing should be thick. So I'll just draw a random rectangle of length. So why I am taking 60 into 60, length and height. Length is 60 and height is 60. Now, in the top view I have length and breadth. First I will just draw the projections. Okay, now length and breadth. What is the value of length? It is 60. What is the value of length? Breadth, it is 50. So 60 comma 50, I will again draw a line. I will start it from here. I will draw a 60 mm line. Okay, I will draw, so sorry, 60, 60, 60. Length is 60. So length is 60 and the height will be 50. Here I will have a 50. Again I will just enclose this with the rectangle. Okay, 60 comma 50, I have marked my rectangle. Then similarly to my left side, the side view I have my breadth and height, or base and height, right? So initially I will just draw this projections from the top view, sorry, from the front view, and the height is going to be my 60 and the breadth is going to be 50. So this is going to be my 60 and this is going to be my 50. Here I will just draw 50, right? I will just mark it and I will just cover this diagram with it. So I have completed all those rectangles. So initially we have drawn the axis, we have drawn the equidistance lines to get the diagram neatly, and then I have converted all those things in a rectangle. So these things will be I have drawn the outside box with the help of these kind of measurements. Now I will start drawing my front. While looking at the front, you can see, right? Just try to compress the component against a wall. You can see only these portions. While looking from the front, you can see this portion. See, we are imagining the component from an infinite distance, right? So all those landing lines, all those curves will look like a straight line. So while looking from the front, I can able to see only this portion, right? So this portion we couldn't get the actual dimension since it is an inclined line. So first what I will do is I will cover this, and the remaining portions will automatically come in this projection. So this is going to be a front view. Front view I will start with 60, and this thickness is given as 8. So from here 60, and from here I will draw 8. And the thickness of the component, I need this thickness, right? I need the thickness. This thickness is given as 15 again in the component. You can see they have mentioned it over here. So this component thickness is going to be 15. So I will draw a 60 mm line, and this distance is 45 and this distance is 15. Again I will draw this entire line, right? So I will draw 60 mm line from here initially. This now I can start drawing in my thicker lines. So I will draw a 60 mm line, and the thickness, this distance is going to be my 8 mm. So I will just draw an 8 mm over there. I will just draw to 8 mm, and this one is 45. So I will draw a 45 mm line. 45 mm line. this distance is going to be 15. So from here I will draw 15 mm line. Okay, 15 mm line. Now I need to just join this L portion, right? This L portion. So what I will do is I can just join this with the help of just this thing, and this thing will be a point. Okay, this thing and this thing will meet at a point. That point is going to be my distance. Now I have drawn this L portion. This up to this I have covered, right? Up to this portions I have covered. Now again I have some kind of portion. From this landing portion, some partial value will be seen from the front view, right? That partial distance is the remaining portion. So always your diagram will enclose in between the rectangle. If you feel any free space over there, and you can found that you have made something wrong in your diagram. So this is going to be my front view. And again, in the front view, you can see this, right? By looking from this component, you can see this, and you can see this component. See, this component is at a height of 40 mm from the top base plate. Top base plate, it is at a distance of 40 mm. So this is my top base plate. From here I have a 40 mm, right? So I will just mark it over here, and this distance to the top I can just join this distance and this distance. So this is going to be my front view of the component. Clear? So I have drawn, initially I have drawn this L portion. This L portion, some remaining portions will be visible for me. I have just drawn it to that extent of rectangle, and I have covered it. And again I can see this, which is at a distance of 40, and I have just covered this. So I think the front view is clear. Now the next thing is to draw the projection lines to draw the top. So this is going to be a top view. What I will do is I will just draw projection lines from all of those cuts. Here I have a cut, so I will just draw some projection lines over there. Here I have a cut, and I have drawn already. I have a projection line over this, right? Now while looking from the top, you can see this entire portion, right? You can see this entire portion, and you can see some cuts over here, and you can see this portion, right? I think it is obvious. And initially I said no. If you are getting any confusion, means you just try to compress the component. Just try to compress the component so that you can see a rectangle. Just close this, close this, and close this, so that you can see this one and this one, and you can see a thickness of some 15 mm line over there with some 3 segments, right? This is what it is. So directly from the projection line, I can take this one, this line, and you can see the entire outer cover of the component. So I can just draw this thicker lines. I can just draw that and do the thicker lines. Okay. Now I will have some 3 segments over there, right? These 3 segments, which is of what is this distance, is of 15, 20 and 15. This distance is 15, 20 and 15. So what I will do is I will mark 15, and then I will mark 20, and the remaining portion will be 15. So I will just draw 15, 20 and right. So from the top view, I have covered this, and I have covered this. Clear? Just shade it so that you can find what are all the remaining portions were left with, right? I have covered this. Now only this component is left off. Okay, from the top view I can able to see this component, so which will be closed to this, and it is at a distance of 8 mm at the center. So what I will do is from here I will just take 25, and from 25 I will take 4 here and 4 here, so that I can easily cover my 8 mm. So what I will do is, here is my 50, I will choose 55, and from here I will take a 4 mm, and from here I will take a 4 mm. And when I just connect it to this, I just connect to this, I will get this entire region of top, right? So I think there is pretty much clear up to this. Now the last and final thing is to draw the left side view of this component, this view, right? Left side view of this component. So while looking from the left side, I can able to see this component, this one, and I can able to see this space, right, where I am putting those into marks. I can see this space, and again this landing line will be seen as a straight line. While I'm looking from an infinite distance, this landing line will look like this, a straight line. So before that, we can just draw some projection lines so that we can easily cover the component. So to draw the projection lines, initially what I will do is I will just take this to XY line. Just take this to all the cuts to XY line as we do it earlier. I'll just take all the cuts to my XY line first. From XY line to XY line, we will cut an arc. Some people will use that 45-degree technique, right? That also you can use, but this will be quite more accurate. Some people, what they will do is they will draw 45-degree line. They will extend this and they will draw this, but this will be quite accurate. So initially I have drawn the projections up to XY line. Now from the center of my axis line, this is my axis line, right? Okay, so from here, this XY line to XY line, I will just take all those curves. XY line to XY line, I will take all those curves. I think you can be able to see what I am doing. From this XY line to this XY line, I will cover, I will take all those components. Clear? Similarly this. Okay. Now from these lines, I will just draw the projection straight. Some people, what they will do is they will take the arc to this equidistant line, but you should not do that. Only up to XY line I should do that, and I can just draw the projection lines. Okay, I think this end will be accurately the same. And from here I have a cut over there, here I have a cut, right? So I will draw the projection lines from here. Here again I have a cut, so I will draw the projection lines from here, and here I have a cut, so that I will draw the projection lines from here. Okay, fine. Now I think we have covered all those projection lines. Now we can come back, right? As we said, I can see this portion, I can see this portion, and this landing line as a straight line. I can see. So first I will draw this portion. When looking at it from here, I can have a 50 and 8 mm block, right? So which is from the projection lines itself, we have get that this is 50 and this is 8. There is no need to measure each of the component if you have practiced the drawing with the help of projection lines. Actually, this is how you should do, and you don't need to measure each and every component. So I have done this, and I have a block over there which will be at a distance, somewhat a distance from here. Ultimately, you can get again that component from the front view. See, this is the block, right? This is what the slanting block or the slanting wall kind of thing we have. So you can see here you have a projection line ending, right? I can clearly see these things. So here is my projection line ending, and at some height it should exist. That height is this landing point is ending at this height, so I can draw up to this slanting line up to this point. I can draw this point and this point, right? Finally I can conclude like this. I can, so I have completed this slanting. Now I have these edges, right? This one, so 15, 20 and 15. So this will be at a height of 45. Ultimately up to this will be 45. You can measure it, or you can easily draw it from the projection. Even if you measure, it will come here. And then I have a slanting arc over there. So from here I will draw this. Here again I have a 15 line. This is going to be my 20. Okay, so this is how you will draw your drawing. So before drawing that, you just try to have a mental picture like, okay, this is how my front view will come, this is how my top view will come, and this is how my side view will come. The next thing is to mark your measurements. So I will just mark some, take some equidistance, like I will take some 10 mm for each of the component. I will just draw this line and use templates to draw the arrow marks. A lot of students are making mistakes over there. I'm just using templates to draw this arrow marks so that I can get a perfect arrow mark to my drawing. I know you all should know how to draw this line. So from this end to this end, the height is 60. So we'll mark 60. And similarly, this height will be 60 again. This will be 60. So I will just draw some random measurement lines over there. Okay, just mark this, and okay, with the help of your arrow marks, you just put your arrow marks. Oops, sorry, to this side. Sorry. And this will be again 60, and this height will be 50, base will be 50. So I will just draw a line. Marking measurements is pretty much important in your orthographic projection, so be careful while marking all those. From this distance to this distance, it is 50. Right, we want to mark 15 mm and 20 mm and 15 mm, you can mark it. So for now, as of now, I am just eliminating the dimension. So this is how you will mark all those necessary measurements in the drawing. So the steps are very simple. Once you get the drawing, you just draw the simple diagram and just find out what will be the length, breadth and height, and this will be your common thing for all the problems. Like in the front view, you can see your length and height, the top view you can see your length and breadth, and in the side view you can see your breadth and height. So depending upon these values, you just draw your rectangles, 3 rectangles, and after drawing these rectangles, you can draw the respective side views, top views and front views, right? So we will meet back in the second question. Thank you.